Okay, this is the fifth and the final video segment on homework number 10. It's these two word problems that I'm going to be doing. Let's start with the first one. All right. So it looks like we have a pole here, which is 50 feet long or high. And there is the sun casting a shadow of the pole on the ground. And the distance is S, length of the shadow. And that angle is theta. So express the angle theta elevation. The angle of elevation theta of the sun as a function of the length s. Well, that's pretty straightforward. So we have in that triangle that you see there, we have tangent of theta, opposite over adjacent, so 50 over s, and therefore s is equal to 50 divided by tangent of theta. Express the angle theta or actually I didn't need to do this. All I need is to calculate theta. So theta is equal to tan inverse of 50 over s. That's all I need to do. Okay. So this is theta equal to tan inverse 50 divided by s, the length of the shadow. Find the angle theta of elevation of the sun when the shadow is 20 feet long. Okay, so all right, so theta is equal to tan inverse 50 over 20. So this is equal to tan inverse of, well, okay, 2.5. Now, if you want the angle in degrees, so we have to do this thing with our calculator, of course. Where is my calculator? Right there. Just wait for 1 second. Okay, free offer. Okay, so if you want it in degrees, make sure that the calculator mode for angle is in degrees. Right now it's in radians, so let me switch it. Let me switch it to degree. Okay, enter. Yep, it's okay now. So we have tan inverse of 2.5. And you get about 68. If I round this thing to uh, one digit, so it's going to be 68.2 degrees. Approximately 68.2 degrees. Okay, that takes care of this problem. Let's go and do the next one. It's a little bit more involved. All right, so number 42. Figure indicates that the higher the orbit of a satellite. So we have a satellite here, okay? Satellite here or there, and it has some altitude from the ground. Obviously, the higher it is, the more area of the Earth is going to cover. Okay. Okay. So let theta be this angle. Theta is the angle that you see here. The radius of the Earth is given to be. Let me write down here. Radius of the Earth to be 3960 miles. Okay. So we have this diagram here. There's the Earth. Think about it as a two-dimensional drawing. Okay, there is the. Oops. Wait a minute. What happened here? Erase this. Erase that. Okay, let's try it again. Okay, here's the Earth. There is the satellite up there. The altitude is high, is h right there. This is the altitude. Now, uh, there's the radius of the Earth. This is the area that it covers. This is 90-degree angle because it's tangent. That ray is tangent to the Earth's surface. So this is R. And what do we got? This angle is theta, same as the other one, of course. And there is the arc length here that is drawn in red for you. This is S. Okay, let's see what it says. Uh, express express the angle theta as a function of h. So if you look at, for example, if you look at this right triangle, okay, in it, this angle is theta. We have tangent of theta. Okay, tangent of theta. What do I do actually? Instead of tangent, let me try a different trick entity. For example, oh, okay, cosine of theta equal to adjacent. The adjacent is the radius of the adjacent side is this, which is the radius of the Earth, over the over the hypotenuse. The hypotenuse is right here. It's this thing, right? So it is h plus r. Okay. Now what do we want here? We want theta as a function of h. So well, it's right here. If you take the cos inverse, theta equal to cos inverse r divided by h plus r. Okay, leave it like that. This is the answer to part A. What about part B? Okay, express the distance s as a function of theta. Okay, so part B, we have a circle like that. This is this is s, and this angle is 2 theta. Okay, so we have, from what we learned in earlier section, we have arc length is equal to the radius of the Earth times 2 theta in radians. So yeah, by the way, this R here is 3960. I didn't replace it, but it's a constant, 3960 down there. The same thing down here. It's 2 times 3960 times theta. Okay, S is equal to that. There is the answer to part B. Express the distance as a S as a function of theta. So now we're going to take S equal to 2 times 3960. Theta is up there. Cosine inverse 3960 over h plus 3960. Or S simply, let me multiply this out. So it's going to be 0.297 cos inverse of 3960 over h plus 3960. So this is the answer to part C. If the satellite is 100 miles above the Earth, what is the distance? Okay, no problem. So it says when h is equal to 100 miles, what is S? We just plug it in. S equal to 7920 cos inverse of 3960 divided by 400 miles above. So we add 100 here. 060 right there. Okay. Uh, what is the distance? Okay, we gotta put this thing in our calculator now. 7920. So I put down 7920 times cos inverse, right? Second function cos inverse. And up there, up in the numerator, we have 3960, and then in the denominator, we added 100 to it. So 4060. And oh, the only problem is that this is going to be wrong answer, because notice that my mode, calculator mode, is on degree. I changed it, so I have to set it back to radian. Otherwise, you get a number that's garbage. Okay. Because this formula S equal to R times theta that we have used is only valid if you have theta in radians. Okay. So, and now we go and enter. I'm done with this mode. Okay. There. Oh boy. So let's back up. How do you get out of mode? That's the thing. Can't remember. Okay. So let's go back here. So let me clear this right there and enter. I want to make sure that my mode is on radians. It is. Okay, so clear this. I don't want to clear it. I don't know how to get out of this mode. Okay, I guess I have to retype that formula. So let's go back here. Or maybe it did clear it. Okay, that must be it. All I have to do is to check my mode, make sure it was actually set on. Yeah, it was. It was okay. So there. 17610. So the answer here is 1761 miles. Okay. All right. So what's the question? Next question is uh, how high how high does the satellite have to be to see both Los Angeles and New York? So the distance between the two of them on the ground is 2450. So we go here. What you want to do is, you see, in this expression, we know that this has to be 2450, and we want to calculate h from it. So let's go ahead and do that on the next one. So we have 2450 equal to 7, or in here it really doesn't matter, 7920 cos inverse of 3960 over h plus 3960. So cos inverse of 3960 divided by h plus 3960 is 2450 over 7920. This is following a simple trigonometric equation. That's what this has to do. So we have 3960 divided by h plus 3960 equal to cosine of, let me cancel these zeros, 2459, no, not 9, okay, divided by 792, okay, and then do a little bit of algebra here. So we have h plus 3960 is equal to 3960 divided by cosine of this number, 245 over 7920. And finally, h equal to this number, 3960 over cosine of 245 divided by 792 minus, there's no zero here, minus 3960. Now we're going to type this in our calculator. So let me go do that. Yeah. So 3960 minus 3960 divided by cosine of, cosine doesn't work, backspace, clear, okay, divided by cosine is right here, cosine of 245, I think it was 245, is that right? Yeah, 245 divided by 792. I think it was 792. 792. Close that. Enter. I think I typed these backward. It's this minus the other one. Okay, it's this guy minus the other one. So definitely there's something wrong there. So let's go back here. I wrote them backwards. And by the way, this let me check the mode first. It has to be radians. It is radian. Very good. Clear. Okay, so back to that screen. Okay, back to that screen. Let's try it. 3960 minus 3960. Is it 3960 or 3690? Let me check. Yeah, 3960 minus backspace divided by cosine of 245. Is that correct? 245 over 792. 245 divided by 792. You close the parentheses. Minus 3960. 3960. It says 197. Yup. Obviously, when notice that when it was 100 miles, we got an S, which was less than 2450. Now it should be around 197 miles up the Earth. What was that 145? 197. If you are 197 miles up the Earth from the surface of the Earth, you can see the satellite can see both Los Angeles and New York City. Okay, that takes care of it. We're done. 5 video segments for homework number 10.